Okay, good afternoon, everyone. Welcome to this session on chaos engineering for SQL Server. Just a little bit about myself first. My name is Andrew Prusky. I'm a field solutions architect at Pure Storage. Before that, I was a DBA for around 15 years. I'm originally from Swansea, but I've been living over in Dublin, Ireland for it's 10 years this year now, so I've been over there a while. I'm a Microsoft Data Platform MVP for the last 5 years. Certified Kubernetes administrator, and I do a whole bunch of stuff in the community, like running events such as 8KB and the newest event in Ireland, Data Kaylee. My contact details on the slide there, at DBA from the Cold on Twitter, and my email, dbafromthecold@gmail.com. So if you have any questions after today, or you just want to talk about tech in general, please feel free to reach out. I'm always willing to talk about this stuff. Blogs there as well, dbafromthecold.com. I've posted multiple articles running SQL Server containers, Kubernetes, and chaos engineering. And then finally, my GitHub account. All the slides and the code for the demos that we'll be doing are on my GitHub account, and I'll post a link to the exact repo at the end of the session. But onto the session. What we're going to talk about today is chaos engineering for SQL Server. Basically, how can we break SQL Server, and how does SQL Server react when it encounters failures in our production environments? So we're going to talk about how chaos engineering has been implemented in a couple of companies. We're going to talk about how we can identify potential issues that we want to test with chaos engineering experiments. Then we're going to look at running a chaos engineering experiment for SQL Server. And at the end, we're going to have some fun with testing one of my favorite topics, SQL Server on Kubernetes. But first things first, what is chaos engineering? Now, the definition on the slide there is from the principlesofchaos.org website, and it's saying that chaos engineering is a discipline or a method of experimenting upon systems to see how they react when they encounter failures. Basically, what we're doing is resiliency testing. How does our, say, SQL Server react when it encounters a failure? Does it react the way we expect it to, or does something else completely different happen? If it reacts the way we expect it to, then we're building up confidence in our systems so that we know that, say, our HA technologies that we've put in place will be there when we really need them. If they don't, then we're running an experiment, we test against it, we analyze the results, we come up with some actionable things to put into our production environment. So we'll see that in the experiments that we're going to run later. So that's all it really is, testing upon systems to see how they react when they encounter a failure. Now, before we go any further, I do want to address a couple of things about chaos engineering, because there are some misconceptions out there as to what chaos engineering actually is. And the first thing is, we are not here to break things in production. If I said to my boss, hey, we're going to start having some regular outages now because I am an engineer of chaos, I'd be marched out the front door pretty darn quickly. We are not here to break things in production. We are here to test our systems to see how they react when they encounter failures. And that brings us on to the next point. Do we need to run all these tests in production, all the experiments that we're going to design? We can. I would say when you first start off, absolutely don't go anywhere near your production systems. Run them in a dev environment, run them in a staging environment, run them in a little lab up in Azure like we're going to do with the demos. Because, again, we are not here to break production. We're here to test our systems. And that does mean we have a couple of caveats. If we are running these experiments in a staging environment, then that staging environment needs to sort of similarly replicate our production environment. Okay, we're not going to get the throughput or the size of databases in the staging environment that we would in a production environment, but we can at least architect them the same. So if you have, say, availability groups in your production environment, have them in your staging environment, and you can run your tests there. So that when you run your tests, you can be, say, 90% sure that the results you get in staging will be the same as the results you get in production. So we're not here to break things. We're here to test things. You don't need to do this in production, especially if you're just starting out designing your experiments. So let's have a look at some chaos engineering implementations. The first and probably the most famous one is, of course, Netflix and Chaos Monkey. Back in August 2008, Netflix experienced a massive outage, a 3-day outage, caused by actually database corruption. And throughout that period, for 3 days, Netflix was down. Now, this was back when they were still emailing DVDs to people. Could you imagine if Netflix went down now? Or during COVID? For 3 days? There'd have been riots. But they got their systems back up and running, and when they got their systems back up and running, they decided to reanalyze their entire environment, and they actually moved to the cloud, AWS. And they went from a traditional monolithic architecture in a private data center to a distributed architecture up in AWS. And when they migrated to AWS, they adopted the mindset of, in order to prevent failure, we will fail constantly. And out of that mindset came Chaos Monkey. Chaos Monkey's sole purpose is to go through their production environment and randomly switch off servers. That's what it does. The idea being that if their systems cannot handle a semi-controlled outage, then they're not going to be able to handle an uncontrolled outage. So it goes through, switches things off, and they monitor it to see how their system reacts. Does it stay online, or do things go down? All the time, building up confidence in the HA systems that they've built, that they know when it encounters a failure, they will stay online. So that's Netflix. That's probably the most famous one. It's freely available. It's on GitHub. You can go and download it and deploy it into your production environment if you want to. I highly recommend you don't do that, but you can do it if you want to. Let's have a look at a couple of other implementations, because Chaos Monkey is just a tool. We do use tools for chaos engineering, but it's more of a mindset and a methodology. And this is ones with Slack and Google. So Slack, they have disaster-based theater, and Google, they have disaster recovery testing. I highly doubt they call it DIRT, but that's what the acronym is. So this is more getting engineers together and thinking about how the systems can fail, and then designing experiments around that to see what they can run to test those types of scenarios. So we have planned failure exercises with a group of engineers working together, and they run it in development first, building up confidence in what they've built before they deploy it to production. Google's got some great stuff here. The SRE team motto, hope is not a strategy. We're not hoping our systems stay online. We are running experiments to test them to prove that they will stay online when they encounter a failure. And the last point there I love as well, controlled chaos. That's what we're doing. We're not just going out, we're not going to a data center just ripping cables out and things like that. We are designing experiments that specifically test a certain scenario to see how things react when they encounter a failure. So, let's get on and let's see how we can start thinking about how SQL Server is going to fail. And the way we do this is we start off with analyzing our environment. Because we can't just go in and start deploying these tests and hoping that, oh yeah, we kind of know what's running in our environment. We need to know from the ground up exactly what is in our environment. So, first thing is infrastructure. Where are we running? Are we in the cloud? We've got a private data center? Are we on premises? And what's running in that data center or in the cloud? Do we have physical machines, virtual machines, some sort of serverless architecture? Do we have a Kubernetes cluster sitting in the corner, scaring everyone? What are we running? And what do we have, once we have that, we need to have a look at the applications. Now, I'm a DBA. I was a DBA. I'm now a field solutions architect. But I was very fully focused on my SQL instances, how they react, building HA, things like that. But how do the apps react when that SQL instance goes down? SQL goes down. Do the apps just start spamming errors like there's no tomorrow, and we have to go in and do something manual to fix them? Or do they have some sort of retry logic in there? How do the apps react, say, the instance comes back up, but the databases are in recovery for an extended period of time, rolling back, say, a large uncommitted transaction? Do the apps just keep hitting it until they pause? What happens when that instance goes down? Monitoring. We need to monitor our SQL instances, and we need to monitor the entire environment when we run these chaos engineering experiments. Now, you can eyeball these tests, and we will do that in the demos, but we need to get as much information as possible when we run our experiments. So we need to gather up so much data that as much as we can, analyze it, and hopefully come out with some actionable results. Because there's no point in just eyeballing it and go, well, yeah, those databases are down for about, 20 seconds. No, we need to know exactly how long they were down for and exactly how long our apps were, say, spamming errors if they were, before they managed to reconnect. And then grabbing all that config info, and we can sort through it and see if there's anything we need to change config-wise in order to prevent this type of failure from happening again. Finally, social. Guess what? You and your team are a point of failure. Who here has ever worked on a team where there's been one person who installed the system, maintains the system, configures the system, and troubleshoots that system? They are the font of all knowledge for that particular system, yeah? Everyone work with someone like that? Oh, yeah. I was that guy. Take that person out of the room. Simulate that system going down. Do the rest of the team have the knowledge to be able to fix that system if it goes down? If they don't, do they have access to get that knowledge? And that could be anything. That could be an internal wiki, blog posts, some sort of documentation, Google Docs, runbooks, really good one, step through troubleshooting, things like that. Take the expert out of the room, simulate the system going down. How does everyone react? Cool. So that's pretty much our environment. From the ground up, what we're running, apps hitting our systems, monitoring, have we got it in place, and then our social as well, the skills on the team. Let's start thinking about how things can fail and what systems we are going to test. And the best way to do that is to start off with a past incident analysis. What has gone wrong in your environment in the past? How were things put in place to prevent that from happening again? And the reason we do this is because we want to get some actual actionable results from our tests. There is no point in running a chaos engineering experiment and going, hey, our system stayed up, it was fine. It reacted exactly the way we expect it to. By the way, we've caused a whole bunch of headaches for everyone else in the company. And then someone turns around and goes, yeah, but the chances of that happening are slim to none. You've wasted everyone's time. We're not doing another one of these. You are all absolutely crazy. We don't want that. We want to say, hey, this has happened in the past. We put this in place. We've tested this. And hey, it didn't work as expected, or it worked as expected. And we're building up that confidence in our systems. A good example would be, we had a standalone SQL instance running in production on a VM. Standing there, something happened, VM crashed. We brought it back up, and then we built some sort of HA technology in. So standard one, always on availability groups, mirroring, failover cluster instance, replication, if you really want pain. It's a viable HA technology. But say we put it a 2-node cluster. 2-node, high available cluster, and we want to simulate failover. Who here has ever built an availability group? What's the first thing you do when you build your availability group? Fail it over, yes. Alter availability group, name failover. That's a real sanitized way of testing the failover of your AG. That is not how your AG is going to fail in the wild. What about switching off the primary node? Turn it off. See what happens. Isn't that a more realistic experiment of how an AG is going to fail? Sorry?
It's great if there are no other AGs on there.
Yes, this is very true. Multiple AGs on a node, risky, can be fun, cause yourself pain. But then, if you're running that experiment, sorry, if no one heard that, it's fine if there's only one AG on the node. Well, if there's multiple ones there, you're still testing the same thing. Are they going to fail over as expected? Is the AG going to react the way we expect it to when that primary node crashes? So that's a good example. Another way of defining tests is something called a likelihood impact map, done by me in, yeah, I'm not great at designing graphs, so here we go. This is pretty much exactly what it says on the tin. We start talking about how SQL is going to fail, and then we rank them on the map by, say, how likely they are and the impact of them. So you get your team, you sit them down, and you get them talking about how SQL is going to fail. Now, it can be like getting blood from a stone at first, but once you get them talking and thinking about how SQL is going to fail, the floodgates open, and it's so much fun. This is a real good exercise to do with your team. Get them talking about how SQL is going to fail, what the impact of it is, and how likely it is as well. And then you rank them on the map. And what you're looking for is 3 or 4 in the red area there, and those are your experiments that you want to first start off with chaos engineering. Now, some people tend to be overly pessimistic or optimistic when they come talking about SQL Server and failures. I'll give you a guess which way I fall. And if that happens, you'll get them clustered either in the red or the green. But if that does happen, zoom in, do it again, and you'll end up with a spread across the graph, some in the red, and those are your candidates for a chaos engineering experiment for SQL Server. So let's start thinking about potential scenarios that we can test. First one, high availability. We've already talked about this. How is our primary node going to fail? We've got a two-node cluster. Instead of ultra availability group failover with T-SQL and failing it back, we just unplug that primary node and see how it's going to go down. Will it fail over as expected? Or is it going to stay in a failed state and we have to go in and actually make some configuration changes? Let's have another one, backups. This is probably the easiest chaos engineering experiment, and I'm stretching the definition here of chaos engineering when I'm saying this, but how often do you test your restores? You can back up your databases all you want, but if you can't easily perform a point-in-time restore of your databases, then those backups are useless. Great example. This is me in a company a few years ago, and I was using third-party software to back up my databases. The reason I was using third-party software, because I was working with SQL 2005, this is how long ago it was, and it didn't have native compression, so I wanted to compress my backups. And it gave me a nice little GUI, and I was backing up my databases, everything was green, I was sitting there happy as a clam, thinking, great, everything's backed up, everything's verified, good to go. One day a developer came up to me and said, oh, we've had an issue with one of our production databases, a load of data has been accidentally deleted, we need you to do a point-in-time restore for, say, 2 hours ago. And I was like, not a problem. I've got my third-party software here, I've got my backups, I've got my diff, I've got my transaction logs, all verified. I can do a point-in-time restore, not a problem. So I picked everything, highlighted everything, ready to click execute, and at the bottom of this little software said, instant restore. I was like, this is a 3 terabyte database. Of course I'm going to want to instant restore it. Who wouldn't? So I did the little checkbox, hit execute, and the backup went up to 99%. There it stayed for 5 hours, and then promptly failed. I hadn't been testing my restores using that feature. So when I really needed it, it didn't react the way I expected it to. And I had to go back and actually manually restore and roll through my logs and back. So I didn't use the software, I did it all. Yes? What third-party solution was it? I'm not going to say. They're not here, but still. So I ended up having to restore manually. It took me about another 6 hours. All the time, I had these developers standing over me going, I thought you said this was going to be quick. And me going, yeah, sorry about that. But we got it working, and then I started testing, and I never used that instant restore feature ever again. Monitoring. Your monitoring systems are a point of failure. In my last place, we used Nagios. Nagios goes down. I don't get alerts. I don't know what's happening in my environment. We have to build some sort of HA for that. But when do we get alerted? Think about, say, we get a runaway transaction against a database, and it's just churning through data. And that transaction log is getting bigger and bigger and bigger. And the disk space on that drive that it's on is getting smaller and smaller and smaller. When do we get alerted? Do we get alerted when it says, hey, I'm 100% full, I'm now not going to have any more transactions against this database? Or do we get an alert saying, hey, there's been a lot of growth here, you need to go and look at this before there's an actual issue? That is a real easy candidate for a chaos engineering experiment. Point your monitoring, add a dev instance, write some horrible T-SQL. If anyone wants a hand doing that, I'm a master. We can run it against the database, and we can expand the log and see when we get alerted. Do we get alerted after there's an issue or before there's an issue? Nice, simple chaos engineering experiment for your monitoring systems. User error. This is probably the hardest and or easiest one to test with a chaos engineering experiment. Who here has ever run an update statement against a production database and forgotten the where clause? Be honest. 100%. Come on, it's so easy. So, story time. A couple of jobs ago, working with probably one of the best DBAs I've ever worked with. I won't name him, John. And He was given an update statement to run against a production database, against a voucher table in a production database to update one row, change the discount applied for that one voucher code. He copied the statement, put it in Management Studio, hit execute, forgot his where clause, updated every single record in that table. The impact of which was that for about 25, 30 minutes before, as we were sorting it out, a 15% discount was applied to every single transaction that company did. A lot of happy customers, not so much happy business owners. The way we fixed it, point-in-time restore, truncated the table, copied the data back in, sorted. But the question here is the deployment pipeline. First of all, should he have been running ad hoc statements against his production database? No. If we shoved it into a deployment pipeline, would our deployment pipeline pick up the fact that it's an update statement without a where clause? Would it highlight anything? Would it do anything? Maybe, maybe not. That's something you can test with your pipelines. I mean, the way we fixed it was we actually restricted our sysadmin access to our AD accounts. And if we wanted to do any writes to the databases, we had to go through a SQL authenticated account. Just put an extra step in there. It's not infallible, but then we had there's a SSMS toolkit that will actually highlight when you run stuff. It'll go, this doesn't have a where clause. Are you sure you want to run this? And again, not infallible because you get really used to just clicking OK, but still, no. Yeah, absolutely, yeah. I know what I'm doing, of course. Okay, let's do one more. Disaster recovery. Who here's got a valid DR plan for their production systems? Who here has tested that DR plan in the last, say, month? Oh, nice. Okay. Oh, hands going down. Okay. No, you put it down naturally. No, cool. Okay. DR sucks because for managers, they think it sucks because it's really expensive and hopefully you'll never have to use it. But you need a DR plan. You need to put it in place, and it needs to be tested regularly because things don't go down at 4 o'clock on a Tuesday afternoon. For some reason, it's always 2 o'clock on a Sunday morning. And at 2 o'clock on a Sunday morning, you really don't want to be enacting your DR plan for the first time and just crossing your fingers and going, I really, really hope this works. You need to have a DR plan in place, and you need to be testing it regularly. Case in point, another story. Different DBA, different job. I'd left at this point, but they were working in a private data center in Dublin. They had no DR plan, but hey, it's a private data center, you know? They manage everything for us. That private data center had a power outage for 4 hours, during which their entire production environment was down. They had no DR plan, nothing. There's nothing they could do other than wait for that data center to come back online. And they were actually down for a little bit longer after the site came up, because when they came up, all their firewall rules were broken. They had to go and fix stuff. So no DR plan, just hoping that things would be okay in their private data center. Remember, hope is not a strategy. So, we've been talking about potential scenarios to test. Let's actually, talking about defining an experiment, yeah, we've got what failure has the highest likelihood, what failure has the highest impact. Remember, we want some actionable results from our chaos engineering experiment. What will we gain from testing the failure? We either gain confidence in our systems, or we get some actionable results to go and apply to our production environment, and then we run our tests again all the time, building up our confidence in our systems. And the last point there is there anything else that can be tested? Now, this is a bit of an unfair question, because it's, Andrew, is there anything you haven't thought of? I don't know, I haven't thought of it. What I mean by this is I've been talking about getting your team together, sit them down, get them thinking about how SQL Server is going to fail. But don't just stick to your team. Go and talk to your system admins, your network admins, your end users, because I guarantee you they will come up with potential failures that you won't have thought of. And to be honest, the end user is the most important thing here. That's why we're here to service them. If they can come up with ideas that you want to test, that is probably the prime candidate for your chaos engineering experiment. So, how are we doing for time? Loads of time. Let's get on and let's talk about running an actual chaos engineering experiment. So, what are we going to test? And we've already talked about it. What happens if the primary node in an availability group cluster fails? So what should happen? Secondary node takes over, listener moves across. If anyone here doesn't know what a listener is the endpoint for the availability group. That's where the apps connect into. That stays online, moves across to a secondary node. You can still connect to your databases. Your apps are still online. So how do we define the experiment? Well, we start off with hypothesis, which is the listener of the availability group remains online. Method, how do we perform this test? Now we can say alter availability group failover, but it's not really how it's going to work in the wild. Let's shut down the database engine service on the primary node, and let's see what happens. Then rollback. When you run your tests, you want to be able to put the environment back exactly as you started with it. Just in case something goes wrong and unexpected results happen, you need to be able to put the environment back exactly the way you found it. And it's really simple for this one. Restarting the SQL engine on the primary node. Nice and simple. So let's go ahead and let's run a chaos engineering experiment. No, but it's pretty much, this is a very simple experiment. We're just making sure that we we're going back to the state the production environment was in, or the test environment was in when we found it. If the listener doesn't, we might have to have some extra actions, definitely. But hopefully, remember, hope's not a strategy. But in this case, we might be. But it's just rolling back, making sure that we put the environment back as we found it when we started. So, yeah, I agree with you saying. The comment was, it's not a full rollback because the listener could remain offline if it's in a failed state. In that case, we would have to go in and double check. But for this experiment, it's fine just rolling back. So we are on our node here, and apologies for my hilariously bad use of. Okay, there we go. So we've got two nodes. We've got Chaos SQL 01 and Chaos SQL 02. 01 is the primary node, 02 is the secondary node. I'm not going to use that again because that's terrible. Right. And the first thing we do when we build an availability group is we say alter availability group failover. And this is going to move the listener from, or the AG, from 01 to 02. And there we go. Nice and quick. If we do a refresh, 01 is now the secondary, and 02 is now the primary. So let's see if we can fail it back the other way. Hit execute. Here we go. Cool. And we've failed back. So we can fail our AG from 01 to 02 and 02 to 01 just using T-SQL. So everything's working there, not a problem. But as we say, that is not how it's going to fail out in the wild. Let's come here and let's run a load of PowerShell. All this PowerShell is going to do is make sure that the listener's online on the current primary, and then it's going to turn off the database engine service on that primary and see what happens to the AG. So we'll have a look. Running through. Here we go. OK, so we're doing just a testnet connection against the listener. That should come in and go, hey, we're online on the primary node. And it's taking some time just to make me sweat. There we go. OK, we are now stopping the database engine service on that primary node. We're shutting it down, just with a stop service force. So it usually takes 4 or 5 seconds. That'll come down. Excellent stuff. And now, what we're waiting for is the AG to fail over, and we're going to do testnet connection again against that listener to see if it's online on the secondary node. So here we go. Wait for it. If everything goes OK, the listener is up and running. We have had a successful failover just by stopping the database engine service. The AG has reacted the way we expected it to. It's failed over, and it's online. And if we check that in Management Studio, 01 is now the secondary, and 02 is the primary. So, not stopping there. Let's continue. Just make sure everything's OK. Yep. Let's fail it back. Let's do exactly what we did with T-SQL and fail it back from 02 to 01. So, starting again, is that listener online on 02? Should be. Yep, we're all good. OK, so let's shut down that database engine service on 02 and see what happens. We should get a nice failure back to 01, exactly as we had with T-SQL. So it's going down. And here we do a little bit of a test. Test net connection against that listener. It should now be on 01. It's failed back. Let's have a look. That's taking a little bit longer than expected. Something doesn't seem right. Waiting for it. Nope, we've got a problem. Our AG has not reacted the way we expected it to when it encountered a failure. What we're going to do is try again. Sometimes it takes a little bit of time for it to fail over. This is Azure, and I'm using an external load balancer. So maybe it was just a delayed reaction for the AG failing over. So we're going to try on that testnet connection again and see if we can connect this time. Issues. Let's have a quick look. Nope, we've got a failure. OK. That hasn't reacted it the way we expected it to. It should have failed over to 01, but it hasn't. The AG has not failed over. It has remained in a failed state when we stopped that database engine service on 02. We've got errors. Our rollback kicked in, started up the primary server. So we've put everything back as it was. If we come back into Management Studio now, we can have a look. Do a refresh here. Yep. 01 is still the secondary, and 02 is still the primary. We haven't been able to fail over from 02 to 01 for some config reason. There's something not right with our setup. Even though we could fail over with T-SQL, when we actually stop the database engine service, things are broken. Now, if we come into the cluster events, we can find out why. Let's have a look. Yep, you are 100% correct. The clustered role has exceeded its failover threshold. It has failed more times than is allowable in its failure period. So, let's have a look here. Let's come into here and properties, failover. So, what these settings are saying is that in every 6-hour period, only one unexpected failure can occur. If more than one happens in that 6-hour period, the AG will remain in a failed state. So we can fail over with T-SQL all we want, but when it actually encounters a failure, like stopping the database engine service, these settings here will prevent a secondary failover. When I designed this lab, and I was playing around with it, guess what the default settings for a clustered role are? Nope, it's this one, 1.6. These are the default settings for an AG, a clustered role even, when you spin them up. So I was sitting there going, I can't remember the last time I checked these settings in my production environment. And I went through and had a look, and there were at least 15 or 20 servers, clustered roles, that had these default settings. Now, we ended up going with 2 failures in every 1 hour. So it can fail and then fail back in an hour. Because if it starts bouncing, then you've really got a problem and you want to have a look at it. So 2 failures in an hour, we thought, fairly acceptable. So let's come back here. Hit OK. And let's run our experiment again. We've made our changes, so we've run a test. We've identified an issue. Let's see if this time, by making that change, we can fail over. So, is that listener online? Is it on 02? Can we connect? Yep, all good. Now we're going to stop the database engine service on 02. Exactly the same as before. We're just saying, off you go. Have we had a failover? Has the AG failed over from 02 to 01 now that we've made that config check? Takes a little bit of time. There we go. And we're coming up. Is that listener online? Has our config change been successful? And yes, it has. We've now managed to fail back from 02 to 01. OK, so that is a very simple, very basic chaos engineering experiment. Just run through, just PowerShell. All that PowerShell's doing, I'm using a little bit of Pester and just stopping the database engine service and seeing how an AG will react when it encounters an unexpected failure. I mean, okay, stop service force is a fairly graceful shutdown. What we could have done is just turn the server off. Thank you. And then up in Azure, there's things like the Chaos Engineering Toolkit, the Chaos Engineering Labs, where you can do exactly that. You can design experiments, and it'll go off, and it'll switch off your VM, and you can watch and see how your AG reacts when it goes down. So, very simple, basic chaos engineering experiment. Now, we've got 15 minutes left, and I want to talk about probably something I've been, I'd say, really interested in, other people would say obsessed with, for the last 3 or 4 years, and that is Kubernetes. Who here has worked with Kubernetes? Playing around? We've got a few. Cool. How are you finding it? Yeah? It's good fun, isn't it? It's like SQL Server. I really like SQL. One of the best things about SQL Server, it's really easy to get into. And one of the worst things about SQL Server, it's really easy to get into. Because you can really easily get into it, and you can do so many bad things, so many bad things. And it's exactly the same with Kubernetes. For those of you who don't know, Kubernetes is an orchestrator for containers, basically. Containerization technology, I was going to say. Basically, if you think about Docker and you run containers on a host, you run your containers there, not a problem. But that's a single point of failure, that one host. Kubernetes gives us the ability to have a fleet of hosts where we can run our containers. And if there's an issue with one host, that host will go down, and everything gets moved across to another host. You can see where I'm going with this? So, when I first started looking at Kubernetes, what's the first thing you do with a new technology? Break it. Yes, absolutely. Trying to get SQL Server up and running, and I was switching off nodes, I was deleting pods, and seeing how SQL reacted when it encountered a failure in Kubernetes. So if we come back over to the lab, I've got there we go, and let's do a plus here. Let's make sure I'm pointing up my cluster. Cool. Let's deploy SQL Server to Kubernetes. And what we have, one deployment, we have a pod. And a pod is basically where our containers run. So we've got one pod of SQL Server up and running in Kubernetes, and we have a service, and that has an external IP, and that's our endpoint. That's where we connect. So we can grab that IP address with this big, long, horrible, and just run select data version. And we should get something back. I think I'm using SQL Server 2019 CU5. Oh, at least it's nice and quick this time. Gee, okay. Chaos engineering in action. Nope, okay. Yeah. Let's try one more time. There we go, cool. So we connect into SQL Server, running in our Kubernetes lab, Kubernetes cluster even. So if you have a look at that pod, we can see that it's age of 63 seconds, IP of 66. Now, Kubernetes has a concept of desired state versus running state. We define our desired state in the YAML files, and we deploy it to Kubernetes, and that becomes our running state. And Kubernetes is constantly checking between the two in a reconciliation loop to see if there are any changes. If the running state, for some reason, never matches the desired state, Kubernetes should automatically fix that for us. So, for example, if we come in and say, grab the pod name and delete it, we're deleting our pod for SQL Server. The running state no longer matches the desired state. Did Kubernetes automatically fix that for us? And we can have a look. We've got a new IP address for 67, age of 10 seconds. Nice, okay. Okay, that's a stretch calling that a chaos engineering experiment, but we are testing Kubernetes high availability. Something went wrong with our SQL instance, say someone came along and accidentally deleted it. Kubernetes automatically said, hey, the desired state no longer matches the running state. I will fix this. No problem. And so I was talking to my boss and said, hey, look, I've got all these tests that I want to do showing you HA for SQL Server in Kubernetes. And he was like, yeah, it's very codey. You know, is there any way you could jazz it up a little bit? I was like, jazz it up? Like jazz hands? What we need is a GUI. We need a GUI to test SQL Server in Kubernetes, like a big flashy thing. So I was like, okay. What if we have a GUI in front testing high availability for SQL Server in Kubernetes, and what if that GUI was Space Invaders? So This is a project I found on GitHub. I've been working with you a little bit, working with you, just like getting it up and running in Azure, just giving feedback. He's a fantastic guy. This is one of my favorite projects ever on GitHub. It's wonderful. Let's have a look here. Let's delete our deployment and our service. And let's come and let's get, say, I don't know, 10 instances of SQL Server up and running in our Kubernetes cluster. That's taking a little bit of time because it's probably got a load balancer in the background. Come on, how long are we doing? 10 minutes, cool. Nope. Come on, there we go. All right, let's get 10 of them up and running. Let's have a look at them. There we go, we've got 10 pods, SQL Server up and running. And here they are. And I can play my game. And I can blow that one away. I can blow that one away. And we can see on the right, containers coming, and then I can't play this very well, so what I can do is just say start, and that will go off, and that will. And we can see, as it goes off, it is killing our pods, and Kubernetes is saying, hey, the desired state no longer matches the running state. I'm going to start spinning them up for you. And we get a whole bunch of them. You can already see that it's struggling to keep up, because those pods aren't coming down. Those two server icons are actually stress tests against the node. It goes off and just starts churning through CPU. And you can see Kubernetes not handling it in any way, shape, or form. So, and this is how I demonstrated Kubernetes high availability for SQL Server in my previous job. You might be surprised to know that I no longer work there. But no, it's one of the favorite projects I found on GitHub. The guy is an absolute star coming up with this. He's constantly like looking after it, deploying it, deploying updates for it. And yeah, he recently brought out the stress tests for the servers and things like that. But no, I'm pretty happy with that. It's a great, great, great project. Okay. So, and that's going to continue going on and on and on and on. There we go. So I've got some resources for you here. The QR code here will take you to the GitHub, my GitHub repo, where all the slides and the demos for the code for the demos that we've been doing today. The top link there is the Principles of Chaos.org website. It's a really great starting point for, say, when you're getting started with chaos engineering. There's a whole bunch of resources there. Then there's the chaostoolkit.org. This is really good. Basically, you can take your scripts, say the ones that we used for the availability group demo, drop them into the Chaos Toolkit, and it'll give you some actual detailed analytical logs coming out of it, exact timings and things like that you can take away and analyze. Then there's a GitHub repo there, Awesome Chaos Engineering, just a whole bunch of stuff that links to different resources for chaos engineering. And then finally there is the Kube Invaders website, GitHub repo, where you can go and download and play around with Kube Invaders. It is absolutely fantastic. I really enjoy playing around with that. Do we have any questions before we finish? Nope. I'm going to take that as I explained everything succinctly and to the point. I'm going to be around all day. If you have any questions, or if you want after the event, please feel free to reach out and talk to me at DBA from the Cold on Twitter, or dbafromthecold@gmail.com. Please leave feedback for the session. Tell me what you liked, what you didn't like. I can make my sessions better. Thank you very much, and enjoy the rest of the conference.